Yes, Bismillahirrahmanirrahim. Now the preference for greatest likelihood. Okay. Uh, for example, lottery P is at least good as lottery Q. If max probability Z is greater than maximum of probability Q, and thus Z belongs to Z, and similarly Z. Clear? Okay, probability, the lottery P is at least good as lottery Q if maximum of probability lottery Z is at least good as max of probability of lottery Q. Now, decision maker has value of Z for each Z belongs to Z, and if P greater than Q, if min of V Z such that probability of Z greater than 0, at least greater than min of probability of value of Z, given that QZ greater than 0. Yeah. What does it mean? First of all, preferences for greatest likelihood. We assume that K probability, the lottery P is at least good as lottery Q. If the maximum value of a lottery, yani probability to assign lottery P, okay, probability to assign outcome, right? It is greater than or equal to the max value of probability to assign lottery Q. Decision maker has outcome, that is outcome, the value against these probabilities, which is called outcome. So that is outcome. So ultimately, when that condition is satisfied, if min of that outcome given that probability, okay, which is greater than 0, means that it should not be equal to 0. Greater than 0 should be greater than equal to min of that one. Why you are comparing the outcome of min? What does it mean? There are two terms. For example, when we say max of A and B, what does it mean? Which value is maximum? For example, it is 100 and it is 50. And I say you are comparing max of A and B, right? This is, let's say, max of A and B is what? $100. Clear? And now you will have another option, max of, for example, this is another outcomes, possible outcome. I say that, okay, let's say here C and D, right? This is another possible outcome. In this condition, the max of this one is, let's say, 50, and it is $0. So I'm saying, okay, max of this one, max of, if it is outcome, for example, is, let's say I represent this outcome is Z, or this outcome, for example, Z dash. Okay, so I can say that ki max of Z is at least greater than max of Z dash. This condition is satisfied. Clear? Right? So if I write this one, ki min, vice versa of this one. So what does it means? Ki what is the min? So I'm saying ki the min of this one is 50. Clear? Min of this one is 50. And what about the min of this one is 0. So I can say that the min of Z is at least greater than equal to min of Z dash. Why I am comparing? What will be the worst scenario if I lost? So what is the worst scenario? The worst scenario in that outcome is I 100% is possibility, any minimum the value of outcome will be $50, and there is the possibility I can win $100 as well, but the lowest value is $50, nothing else. Here, there is the possibility that I can win $50 max, and the lowest value is $0. So, the min of this one is better than the min of this one. Clear? Why? Because we behave rationally. So, being a rational individual, we are considering what will be the worst scenario if I select these lotteries. So the worst to worst scenario should be better than the other one. That is my objective. Clear? So I can write this one. Okay, if that lottery is at least good as lottery Q, so it means the max of that lottery, clear, probability of that lottery is greater than the max of this lottery. Here you are going to compare what is the chance. Ab dekho, now compare it is here. Okay, for example, again you will have certain level of the probability here. For this outcome, you will have some probability. Clear? Okay. So let's say I assign here, okay, this is 1 over 2 and this 1 over 2. Okay. The probability we have discussed in previous lecture, the probability to get $100 is 1 over 2. Clear? And the probability to get $50 is 1 over 2. Right? So what is the max's probability? Maximum probability is what? For this 1 over 2. Clear? But here, if I say the probability is, for example, I say, okay, let's say it is 0.9 and this one is 0.1 for sake of understanding. So now this condition is not going to satisfy here. What is the max of this probability? Maximum probability. The maximum probability is 0.9 here. Clear? And here the maximum probability is 0.5. So now you are not satisfying this condition. Clear? What does it mean? I say if this condition is hold, so the chance to get maximum should be greater than chance to get this one. Clear? अब यहां मैंने क्या कहा कि चांस टू गेट minimum value is 1 over 2. Clear? Right? And the chance, here the condition, the maximum value which is not going to satisfy because it is the 0.9 and there is 0.5. Clear? So simultaneously both conditions should be satisfied. We will have a numerical example, then it will more clear for you. Clear? So now consider, for example, again Z, A, B, C. Again $1,000, $50, again $0. Right? The same example. Now one important thing, the P is 0.5, 0.5 and 0, and Q here 0.5 and 0.5, oh sorry, 0.25 and 0.25, and similarly PQR, TR. R, PQRT. R is 0.01 and similarly 0.99 and 0, and T is here 0.98 and similarly 0.01 and so on 0. Yes. Up now, first of all, what is the max according to this one? Because we have to rank out these lotteries. So first of all, we decide the maximum value of probability for outcome in each lottery. Okay, that is lottery 1, yani lottery P, and these are the probabilities for each outcomes. Am I right? This is lottery Q, and these are the probabilities for each outcome: A, B, C, A, B, C, A, B, C, A, B, C. Right? Clear? Now select the max of these probabilities. Max of probabilities in each lottery. Okay? In each lottery. Right? So what is the max of this one is 0.5. Am I right? And max of this one is 0.5, and similarly the max of this one is 0.99 and the max of this one is 0.98. Yes. Now first of all, compare these lotteries and rank these lotteries as well. So when we compare these lotteries, so which lottery is better than? So it means the lottery R is more preferred as compared to other lotteries. Clear? Because the max of these lottery R is highest as compared to other one. The second rank is lottery T, and the consumer is or decision maker is indifferent between P and Q. Am I right? Okay, so I can conclude here, when we rank these lotteries, rank these lotteries, yes. Okay, first of all, are preferred more, are preferred on, yes, on. Next is T, comma, P, comma, Q. Am I right? So I can write this R is at least better than T. Am I right? Clear? And T is at least better than Q, P and Q, and it is you are indifferent. So now the first condition is clear. You have to compare the max of losses, okay, of each payoff. ठीक है. So it means in the first step, for uncertainty, I told you that first of all you have to rank out the lotteries probabilities to assign each outcome. ठीक है, यानी you have to compare the lotteries. So whenever you are going to compare the lotteries, you should know about the assigned probabilities, and you have to, then you will be realized which lottery is better than other one. Clear? That is kind of the rank or realization of each lotteries here. Clear? बिल्कुल. So now next is के decision maker, and we can write here V of A here. कि V of A, that is actually this one. ठीक है? V of A is $1,000, and V of B is $100, and similarly V of C is $0. Okay. Okay. So in the second scenario, you have to justify this utility, this function. Okay, so min of vz, min of outcomes. Clear? Subject to the probability. Okay, what condition is here? The probability should be greater than 0. Okay, so when the probability is equal to 0, so we will not consider that outcomes. So in some here, in there are two cases. There are three lotteries where the outcome of C, probability of outcome of C is 0. Clear? In this lottery, clear, we are not going to be considered that this one. And similarly, here you have the probability of outcome C is 0. Clear? So in case of T as well. So according to that constraint subject to the given condition that you have to satisfy here, so you will not consider when you are playing the lottery P, you will not consider the outcome C. Okay, am I right? Right. And similarly, if you are playing the lottery Q, you will consider the all outcomes, yani A, B, C, and all three. And in case of R, you will not consider again the outcome C. Why? Because it's the probability of that outcome is zero, and similarly in case of the T as well. You got my point? Otherwise, that constraint will not satisfy. If I write this one, okay, and this one, so then you can consider. But I give the condition is greater than zero, so in that condition, you will not consider that lotteries. The lottery outcome of C in these lotteries. Clear? So now move forward. So you have to consider the min. Again, we have to told you the min. Why you are considering the min? Because to consider or to calculate the worst scenario. That's why we are going to compare the min of each outcomes in each lottery. Clear? So move forward. Okay. So yes. So again, in case of lottery P 0.5, 0.5 and 0. Okay. Now compare is min of VZ. Okay. So in case of P, the min of VZ is, yes, when you have a lottery P, the min of VZ is what? Uh, the $50. Okay. The $50 is min of V is $50. Am I right? So I will write here is dollar 50. Clear? And when you decide to play lottery Q, the min of this one, because you are not going to be considered this one. See, we have discussed the min of Q, again point 5 and point 0.25 and 0.25. So yeah, all outcomes are considered here. So what is the min of all outcomes here is $0. Okay, the min you have to decide that compare the worst scenario. So worst scenario in case of the Q is $0. So $0. Clear? And in case of the lottery R, is the probabilities is 0.01, 0.09 and 0. So the outcome um, is what again dollar 50. Am I right? Dollar 50, and similarly T is okay. Uh, what about dollar T is third one is does not consider, and the dollar 50 again. So 0.98 and similarly 0.01 and again it's 0. So dollar 50, right? Yeah. So now look at this one. Which event is better according to these lotteries and outcomes, because we have to satisfy simultaneously all both constraint. So when we compare that, what we decide, min of uh, min of payoff, clear, min of visa subject to the probability, given the probability should be greater than the min of other one. Okay, so here according to the min of this one, right? So we are indifferent between p, r and t. Okay, right? And we do not prefer q, right? Because the payoff is zero here. So it is completely rejected because the payoff is zero and we are indifferent between P, R and T. Now, but there is another constraint is here. Okay, you have to compare the max of probabilities. Okay, so the max of probabilities in these lotteries, although the min of uh, are equal to and greater than and equal to each other, clear? This condition is satisfied, right? So, but the probabilities are here. That min of is has highest probability in the lottery R because it is 0.99 as compared to other one, because in the min of $50 has 0.5 probability in P and 0.98 in T. So R is more preferred as compared to these one. Clear? ठीक है. So I can conclude here this statement. Just write a conclusion here. बोर्ड छोटा है यार एक्चुअल में. Okay. So initial consumer first decision maker is indifferent, indifferent among, indifferent among P, S, R and T, right? Because men of reasons for all lotteries are equal to each other. Am I right? For all lotteries are equal to each other, and similarly, but one decision maker check the associated probabilities with this min of payoff. So decision maker rank associated probabilities probabilities with min of vz. So lottery lottery R is preferred on lottery T, am I right? And T preferred on P. Okay, because the T is the this one, and here the value you have zero point 0.5. So T is preferred on P. Clear? That's a conclusion. So I think today we should stop here, and in the coming class we will discuss uh, about the expected utility functions and axioms related to the expected utility functions. So this is another lengthy debate and some technical axioms. So inshallah in the coming class we will start these two topics. Okay, and after 10 to 12 lecture, we will move towards the game theory. Clear? But you have to watch all the videos because these are some introductory videos and some technical discussion related to the game theory. We will move forward. वो सारे आपको वहाँ से cover कर कराने पड़ेंगे. I will not cover here in the classroom. Clear? So thank you so much. Allah Hafiz.